Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and this particular question belongs to paper 9709/42 for the session October November 24. Let's solve question number 6, which says a particle P travels in a straight line starting from a point O with velocity 6 meter per second. The acceleration of P at time t second after leaving O is a meter per second square, where a is equal to negative 1.5 t raised to half for 0 until 1 second, and a is equal to 1.5 t raised to half minus 3 t raised to negative half for t is greater than 1. Find the velocity of p at t equal to 1. Well, so in the question, acceleration has been given and we are to find the velocity. And for finding velocity, if we want to convert back from acceleration to velocity, we just do integration. So let's integrate the first expression. Okay, acceleration is given as negative 1.5 t raised to half. Well, then if we integrate this in terms of second or time or dt, it is going to be negative 1.5. Then look at this. If we add up 1 to the exponent, it is going to be half plus 1 means 3 over 2. So if we multiply, it is going to be 2 over 3. Then the exponent of t is going to be 3 over 2 plus the constant number. Or if we integrate acceleration, we know that this is velocity. So velocity is equal to 2 into 1.5, that is negative 3. So it is going to be negative t raised to 3 over 2 plus c. Now let's see what is the constant number. They have told when the particle start from the point O, the velocity was 6. So t is equal to 0 when velocity was 6. T equal to 0 when the given velocity was 6. So if we substitute this value of t, so negative t was 0, so it is 0 plus c is equal to 6. Hence our constant value is 6. Or let me write just beside this. Or c is equal to 6. So simply we can write our velocity. Hence the expression for velocity is v is equal to negative t raised to 3 over 2, 3 over 2. Let me write more distinctly, 3 over 2. 3 over 2 plus c, constant number is 6. Now they have told us to find the velocity when t is equal to 1. So just substitute this t equal to 1. Let us write t equal to 1. T equal to 1 when v is equal to, look at this, we have written t equal to 1. So it is 1 raised to 3 over 2 plus 6. Hence our final velocity is going to be, look, the exponent of 1 is 3 over 2, means it is cube. Okay, so if we write this it is going to be negative 1, or I can show you that whatever the exponent on 1, it must be resulted in 1. So negative, I mean 1 raised to something is 1, so negative 1 plus 6 means 5 meter per second. That is what the final answer is. Now we are moving on to the immediate next question. The immediate next question says, given that there is no change in the velocity of p when t is equal to 1, okay, then find an expression for the velocity of p for t is greater than 1. Let us change the color of the ink. Well, so they have told that there is no change for the second phase. If we look, the second phase expression for acceleration for the second phase is this. So we will write a equal to 1.5 t raised to half minus 3 t raised to negative half. So let us write a is equal to 1.5 t raised to half minus 3 t raised to negative half. Negative half. Well, as we did in the previous case, we are to find the velocity. So for velocity, we'll integrate the acceleration. Let us integrate this acceleration. Integration of a in terms of t equal to, let us do the integration. If we add up 1 to half, the exponent is half, so it is going to be 3 over 2. So 3 over 2 means we'll have to multiply by 2 over 3. 2 over 3. Well, then the exponent of t is 3 over 2, we have just found, minus 3. Then here it is negative half. Okay, so for negative half, if we add up 1 to this negative half, it is going to be half. So if we multiply half, it is going to be 2, and that is how much? Going to be 1, because half means minus half plus 1 is equal to half, positive half. So if we make the reciprocal of half, it is 2. Then the exponent of t has already been obtained, it is half. Half means it is square root. Well, we will not forget to write the constant number. Well, then it is going to be velocity is equal to 1.52 times equal to 3, so 1, it is nothing but 1 3 t raised to 3 over 2 minus 3 to the 6 t raised to half, then it is going to be constant number. Now let's see, they have told that t is equal to 1 when v is equal to, let us see, for the second phase velocity has started from 5. We have already obtained in question number, in solution number a, that velocity was 5 when time was 1 second. So it is 5. So let us substitute the values. What are the values? It is t raised to 3 over 2, t raised to 3 over 2, t raised to 3 over 2 minus 6 t raised to half plus c. I think we can write it directly instead of t, because we have already written t equal to 1. So let us write here 1 instead of t. Okay, it is going to be 1, and so is this one. Okay, because we have already mentioned that t is equal to 1. So 1 raised to this into 1 raised to this. Or on the left side, what is going to be, whatever the exponent on t is, on 1 is, it is actually 1. So 1 minus 6 means minus 5. So minus 5, if it is transposed to the right side, it is going to be plus 5. So hence our C is going to be 10. 5 plus 5 is equal to 10. So what is the expression for velocity? We can now write the velocity is equal to, hence our expression V is equal to, this was our expression, this was our expression. So our expression is V equal to t raised to 3 over 2 minus 6 t raised to half plus c equal to, we have already obtained 10. So this is what the expression for the second part of the solution. Let's move on to the question number, third part of the question. Yes. Then third part of the question is telling that given that the velocity of p is positive for t is equal to or less than 4, find the total distance traveled between t equal to 0 and t equal to 4. Well, let us have a look at the velocity function. Look at this. This is the velocity function. Okay, when t was 1, look at this, when t was 1, for the first phase our expression was this, okay, which is positive, okay, because velocity was 5 when t was 1. When t was 0, even then velocity was positive, okay. Then let us see, when velocity, for the second phase, t is equal to greater than 1, even then also it will be positive, because they have already written that it is positive, means t raised to 3, whatever is the value of t, look at this, it must be positive. I think you have got my points. Here if you substitute any value, any of the value, you will get a positive value of v. That means from 0 until 1 the graph was positive, okay, the graph was positive. And for the last phase, they have already mentioned that this t was until 4 second it was positive, given that the velocity of pu is positive. So whole of the graph will lie above x-axis, means for positive value, okay. So our graph will look like somewhat, this is our t seconds. Graph is not a mandatory part of your solution, yet I'm showing you so that you understand it better. This is v meter per second, v meter per second. And initially when the particle was passing through the origin, we have not forgotten that it was actually 6 meter per second, okay, 6 meter per second is the loop. When t is 0, the velocity was 6. So the graph will look like, so how will the graph look like? The graph will look like, let us write here 6. This one is 6 meter per second. So graph will look like this way, okay, just this way. And here there was 1 second, let it be 1 second over here, and 4, they have already mentioned that until it is 4 second the velocity was positive. So if we want to find, they have told us to find the distance from beginning to until 4 seconds. So this is our distance. So this part is our distance which is lying above the x-axis. So it must be positive. There it will show positive value. Okay. But there are two phases. But the most important point from this graph, please don't get confused that we will find directly the distance travel from 0 to 4 second, because if I clarify the graph even more, it was not actually constant acceleration. Look, acceleration was different, means the velocity was also different, it is not constant. Suppose it was the graph, yes, the graph was not, this is not a constant, deceleration or acceleration. It is, the graph was like, suppose something like that. That means until 1 second it was the first phase when acceleration was constant, but for the next part acceleration was not as it was for first second. So let it be shown, it may go down this way, not this is the, something like this. Okay, so what I am trying to make you understand that it will not be constant acceleration. Acceleration is not constant, that's why curve will not be a regular curve. Okay, something like this. After 1 second it may look like this. Okay, let me erase these unnecessary parts. Yes, the graph is not essential to be drawn, but yet if you want to understand this, because in some other question the graph may be the part of your solution. So if you don't know how the graph is moving, it will be very difficult for you to understand and to find the total distance. Because from 1 until 4 second, let the 4 be, the 4 may be over here, 4 may be over here. Okay, well, so that is what the part of the graph. Okay, which is not the main part of our solution, but we have done this so that you can understand it better. So our distance is required not until this, distance will be until this, until 4 second. Okay, until 4 second, not more than that. Let it be connected, it will connect. Okay, and we require the distance from 0 until 4 seconds. Well, so we know how to find the distance. Distance is the integration of velocity, you know it, integration of velocity. So let us integrate the first expression of velocity. For what will we write? Yes, for the first phase, for until first second, for 0 until first second, displacement or distance, whatever you tell, distance is equal to distance is equal to, sorry, velocity should be, we will integrate the velocity, distance s1 is equal to integration of velocity, integration of velocity in terms of time, from until 0 until 1 second. Okay, so what is the expression of velocity? Expression for the first phase, the expression was, let us have a look at this. First expression was this, This one was the first expression. Negative t raised to 3 over 2 plus 6. Negative t negative t 3 raised to 2 plus 6. Now, if we integrate each of these, we will have to use the integration symbol. Well, this is integration symbol, and minus symbol can be written just before this. We can write here minus symbol, then equal symbol over here. Okay, then 0 until 1 second, as well as 0 until 1 second, then in terms of t, I mean time. So if we integrate this, what is it going to be? If we add up 1 to the exponent, it is going to be 5 over 2. So negative 5 over 2 will be made reciprocal, that is 2 over 5. Then the exponent of t is going to be 5 over 2, as we have already found, and the limit is 0 until 1, plus here also we can write the constant value of 6 will produce t, and the limit is 0 until 1, plus constant number. As there is no constant number, let us have a look at the graph. The graph is, look here, when t was 0 at the beginning, t was 0, our distance was what? The distance was also 0. That's why there is no constant number at the beginning. Okay, so it will be, there will be no c unnecessary. C is not necessary to be written here. Let us erase this. Okay, so let us calculate this. After calculation, it is going to be, look, it is negative 2 over 5, negative 2 over 5 into, if you multiply, I mean 1, whatever the exponent on 1, it is 1. So it's going to be just nothing but 2 over 5. For 0, there is no value. And if we consider t is equal to 1, it is going to be 6. So finally, what is it going to be? It is going to be 5 6 are 30 minus 2, so 28. It is 28 over 5 for the first phase. Now for the second phase. For the second phase, we will write for t equal to, for, or can we write just beside this? I think we can. For the second phase, and second phase is also lying above, the graph is lying above the x-axis, so it must be positive. For 1 until t less than or equal to 4, v is equal to, already the expression has been written in question number A. We have written for the second phase, v is what? T raised to 3 over 2 minus 6 t raised to half plus 10. So t raised to, it is going to be t raised to 3 over 2 plus 6t, sorry, not plus, it should be negative, minus 6t raised to half plus constant number was 5 plus 5. Now we are finding displacement. So this is the second phase. It is going to be, no, don't use this. Will you write directly? Yes, let us write directly. It is going to be 1 until 4, t raised to 3 over 2 minus 6 0, sorry, 1 until 4, 1 until 4, and t raised to half plus, if we integrate 5 once, it may be written 0 until 1 until 4, 1 until 4, 1 until 4, and in terms of t equal to, if we add a 1 to the exponent, it is going to be 5 over 2. So if we write here, it is going to be 2 over 5. Then the value of t is going to be t 5 over 2, and limit is from 1 second until 4 seconds. Then 6. Then exponent is going to be, look at this, it was half plus 1, 3 over 2. So 6 into 2 over 3, and the exponent of t is going to be half plus 1, 3 over 2, 3 over 2, and the limit is from 1 until 4 second, plus 5. For constant number, we know, for the constant number our integration will be just t. So it is 5 and t, and the limit is from 1 until 4 second. Well, it is going to be, look at this, 4. Let me explain this and expand this. So it is 4 raised to 5 over 2. Okay, 4 raised to 5 over 2 minus 1 raised to 5 over 2, minus, it is going to be 3 2s are 6 2s are 12, means it is going to be 4, and t raised to 4 raised to 3 over 2 minus 1 raised to 3 over 2 plus 5. And this can be written very simply. Look at this, 5 into, from 4 if we subtract 1, it is going to be 3. So let it be written directly, it is 3. Well, after that, now how will you do it manually? You can do it easily using your calculator, but if we do manually avoiding calculator, it is going to be, look at this, 4 means 2 square, so 2 square into 5 over 2, minus, if we write anything as exponent on 1, it is going to be 1. Okay, 1. And the second part, if we write here, 4 means 2 square, so 2 square means 2 into 3 over 2, 2 into 3 over 2, and 1 raised to something is 1, minus, sorry, plus 5 plus 3, it is 15. Okay, so after simplification, look at this, what is it going to be? These two can cancel this one, so 2 raised to 5 means how much? 32. 32 minus 31, so 31 2s are 62, 62 over 5, 62 over 5, minus, here if this is cancelled by 2, so 2 cube means 8, 8 means 1, 7, 4 7 means 28, plus it was 15. Okay, so what is it going to be ultimately? Or we can write over here, it is going to be 5, 5. Then 5 15 is 75. I think we have been being making a great mistake. This should not be actually 5. Look, this is not 5, I think. Let me erase this. This is no more 5. It is not 5 at all. It is not 5 at all. So this should not be 15. Let us go back to the expression. Was it 5 or not? Look at the second expression. It was plus 10. So it should be actually 10, not 5. Okay. So let us write 10 instead of 5. If it is written 5, what will happen? If it is written 10, so it is going to be 10, not 5. Let us write here 10, and this is also 10, not 5 at all. It is going to be 10 plus 10. Hence our next step is going to be, here there will be 10, and finally it is going to be 10 into 3. 10 into 3. So what is it going to be? It is going to be 30. 30. If it is 30, here also it is going to be 30. 30. Well, now if we calculate, look at this, 62.62 over 5, that is 5, 12, 12.4. So 12.4, 42. Let us write as a fraction. So 62 and 530, if I elaborate this, it is going to be 62 minus 62, 62 minus 528s are 140 and 530s are 150. Okay, so what is it going to be? It is going to be 150, so 10, so it is going to be 72. That means 72 over 5 equal to 72 over 5. Now the total distance, we have got the distance of each of the phase. Then we can write the total distance. Let us write here total distance. Total distance equal to, okay, in the first phase the distance traveled by the particle was 28 over 5, 28 over 5 plus the second distance was 72 over 5 meters, 72 over 5 meters. Now if we add up 28 plus 72, it is going to be 100 over 5 equal to 20 meters. 20 meters. So total distance traveled by the particle was 20 meters. So that's all about from me, and I tried to explain every tiny part of the solution. I wasn't in a rush, that's why it might take longer time, but I believe that I may spend longer time to understand better. That's why I have made it lengthier. Let's see the solution to the first question. This is the first question, and then for the second one we can have a look at this. So that's all about the solution to this question. And may Allah bless us all with the beneficial knowledge. Allah Hafiz.